Welcome to National Chemistry Week. We're going to celebrate marvelous metals this week by looking at a particular metal. We're going to look at pennies, and we're going to see what metals pennies are made of. If you take a roll of pennies and you open it up, you'll find that there's differences in those pennies. One of the ways to note those differences is to simply weigh them. So I'm going to take a penny and I'm going to put it on this balance and weigh it. You notice that this penny weighs just under 2.5 grams, 2.48 grams. If I go through this stack of pennies and weigh them all, I find that some pennies, not very many, have a significantly different weight. So this penny weighs 3.11 grams, and we'll notice that a smaller number of pennies in the roll will have a similar weight. You may find a penny that looks significantly different than the rest. Here's a penny that looks a lot different than the rest. If we weigh it, its weight is different. But what makes this penny even more interesting is that if you take a magnet and hold it to that penny, it will stick to it. This penny is made of steel. These pennies were made after 1983, and they actually contain mostly zinc. The pennies that are heavier, around the 3-gram mass, those pennies are mostly made of copper. And then in 1943, we were at World War II, and we need the copper to make ammunition. So that year, they made pennies out of steel, which is mostly iron. Next generation science standards, one of the requirements for students is to analyze data. We can do a fun activity where we use pennies to make a graph to analyze data. Let's see how we can do that. What I have here is a group of post-1983 pennies. So these pennies are all very similar in mass. And then I have a container here that has an unknown number of pennies in it. Your students might ask you to say, well, if I just weigh one penny, can't I just use that to determine the number of pennies by weighing the container? The problem you'll find is when you weigh a lot of these pennies, you'll find they don't all weigh exactly the same value. We have a force sensor set up. I'm going to take an identical container, put it into this cup, and I'm going to zero out the data so that the weight of that container is no longer affected. And I'm going to start collecting the weight of these pennies in groups of 5. I don't have any pennies in there right now, so I'm just going to take that data. Let me keep that point. The total number of pennies in there are none in there right now. Let's put 5 pennies in. And I have 5 pennies in there, so I'll keep that point. I'll add 5 more pennies. Now I have 10 pennies in there. Let me add 5 more. Total of 15 pennies in the cup at the moment. Let me add 5 more. Total of 20 pennies in the cup. 5 more. All right, I'm out of known pennies, so we're going to stop collecting data. This data looks extremely linear, so let's fit a curve to that so we have a nice linear fit. Now, we want to know how many pennies are in here. Let's weigh the container with the pennies. 0.31 newtons. Let's compare that to our graph. There's 12.5 pennies. Let's count the pennies. There's 5. 5 more. 12. The data tells us that there should be 12.5 pennies in there. How are we going to deal with this discrepancy? That the students should be able to analyze the data, and they're going to have to try to come up with an explanation as to why the actual number of pennies does not compare exactly with the value on the graph. So what other activities could you do for National Chemistry Week, Marvelous Metals, with pennies? We would love to hear from you and hear your ideas.